Listen up, brand new images of 3i Atlas just dropped, and they may change everything we thought we knew about this interstellar visitor. These last-minute observations reveal something absolutely unexpected. Atlas remains a single body and displays multiple jets pointing both toward the sun and in the opposite direction, and some of them are surprisingly well collimated. That's right, firm, defined jets that do not behave like the diffuse tail we expect from a normal comet. Who captured these images? Recent records include work from astrophotographers like Satoru Murata, François Cougal, and observations coming from Japan and Thailand. These photos were taken at different moments between November 11th and November 17th, 2025. But all of them point to the same enigma. Something very strange is happening with 3i Atlas. But here's the thing. What do these images actually mean? Specialists, amateurs, and respected researchers are laying the pieces on the table, and the pieces don't fit into a simple natural comet explanation. The scientific community has already published technical analyses explaining what was observed, and bolder interpretations have begun to gain momentum. Today we're going to break all of this down. The data, the contradictions, and the hypotheses that simply cannot be dismissed. Because if what some scientists are suggesting turns out to be true, we're not just looking at an unusual comet. We could be witnessing something that fundamentally changes our understanding of what travels between the stars. Here are the most relevant elements appearing in the images. Multiple well-defined jets, some pointing toward the sun, others pointing the opposite way, including a very pronounced anti-tail. In several stacked exposures, Atlas appears sharp, while nearby stars show typical long exposure trails. This is already strange. A moving object should manifest similar smearing when exposure time is long, yet Atlas often appears free of those smears. The coma, the atmosphere around the object, shows changes in brightness and even color across images and time lapses, sometimes more orange, sometimes greener, sometimes paler. Experienced observers, including high-level amateur astronomers who used to be skeptical, reported difficulty fitting this behavior into known rules for cometary nuclei. And there's more. Rotation measurements suggest a period of about 16 hours. Yet even with this rotation, the jets remain organized, not stretched into a spiral as expected. All of this forms a pattern that simply does not match a normal comet. And this is exactly where the problem becomes deep. In typical comets, gas and dust jets formed by sublimation tend to be distorted by the combination of nucleus rotation and solar wind. The result is usually a fuzzy, dispersed structure that doesn't maintain sharp features when the nucleus spins. In Atlas' case, however, the jets appear highly defined, and in some records, they extend across enormous distances without dissipating as expected. This raises crucial questions about the speed and nature of the material and the mechanics generating these jets. Are we looking at volatile pockets strategically scattered across the surface? Could fragments be evaporating and creating solid-looking structures behind them? Or are we observing something that escapes normal cometary physics? Recent research revealed numbers that make a natural explanation even harder. To produce the observed luminosity through relatively large dust particles, the required mass loss would have to be enormous, and in energy terms, demand a source that doesn't match the estimated size of the object. In clear language, for certain dust grains or fragments to generate the brightness observed, Atlas would need to release mass at a rate requiring more energy than the surface of a small body, with the diameter estimated from high-resolution images, could provide through solar irradiation alone. This doesn't mean natural explanations are ruled out, but it does mean that any natural hypothesis has to face uncomfortable numbers and justify how a relatively small object can produce such extended jets without breaking apart. Given these numbers and the behavior observed, some have proposed radical hypotheses. One of them, technical and straightforward, is the possibility of artificial propulsion. Collimated jets functioning like thrusters, capable of producing far greater impulse than simple outgassing. If technological thrusters were oriented so that one jet pointed toward the sun, the result could be a calculated acceleration that moves the object off gravitational influence in a way inconsistent with natural motion. In other words, deliberate maneuvers. Remember, this is a hypothesis, not a conclusion. Still, the consistency of the jets and their resistance to dissipation have made this idea plausible enough to be seriously discussed by some scientists. But wait, there's something even more extraordinary being proposed. Another hypothesis, more sophisticated and less intuitive, is the idea that Atlas could be a plasma entity, meaning a non-organic life form based on plasma structures or electromagnetic fields. This hypothesis suggests the object could maintain self-organized structures in vacuum, interact with electromagnetic fields and particle storms, modify its appearance, brightness, color, shape, in response to spatial stimuli, and collect information from its surroundings, functioning in a sense like a living probe. If this sounds improbable, remember that our definition of life is narrowly based on carbon chemistry. The idea of a parallel energetic biosphere would require expanding that concept. And if true, it would be one of the greatest scientific revolutions of all time. While scientific hypotheses pile up, there's also a public narrative battle. Official voices repeating comet endlessly, commentators accusing image suppression, channels raising conspiracy theories, and amateur observers reaching very different conclusions. Some influential specialists try to reconcile the data with natural explanations, citing, for instance, unusually large dust grains that might explain the anti-tail. Others point to contradictions, color changes, anomalous polarization, a trajectory coming from Sagittarius, and calculated approaches to planets that seem more than coincidence. The result is an explosive mix, serious science coexisting with speculation, and the public trying to figure out what is evidence, what is narrative, and what is convenient silence. Among the voices that stood out in recent days are experienced researchers and respected amateurs. Some highlighted images with jets that seem to turn on and off, apparently selectively. Time lapses where the coma shifts position and color within short intervals. Skeptical observers who for the first time admitted they don't know how to explain what they saw, which in itself signals a phenomenon that exceeds trivial interpretations. These reports reinforce the sense of urgency. This isn't just online opinion, it's repeated observations by professionals and amateurs with technical know-how. In response, the scientific community has proposed concrete work fronts. High-resolution spectroscopy to measure jet velocities and distinguish natural outgassing from potential artificial jets at much higher speeds. Plasma simulations to test whether self-organized structures can survive and remain cohesive under interstellar conditions. Historical data reviews to search for similar patterns that might have gone unnoticed. Coordinated observations from multiple telescopes in different wavelengths to understand composition and light polarization. If these fronts move forward in the coming weeks and months, we may narrow down the possibilities and perhaps point more firmly toward an explanation. Even so, contradictions remain. Why has an object with such active jets not fragmented during perihelion? How do we explain rapid color shifts without an obvious chemical source? How do we reconcile rotation measurements with jets that do not unwind into spirals? Why is there apparent resistance from certain official channels to release some images at the same pace as the amateur community? These are fundamental questions that demand clear answers, and for now, they only deepen the mystery. If Atlas is in fact a technological artifact or a plasma-based life form, the implications are enormous. Our notion of what travels between stellar systems would need to expand. Detection and interpretation methods for space signals would need revision. Immediate international collaboration would be required to observe, model, and possibly intercept signals or maneuvers. And perhaps most importantly, we would have to face the possibility that the universe hosts intelligences or processes that do not fit our categories. But these are speculative outcomes. To reach them, we must verify data step by step, refute inconsistent hypotheses, and maintain scientific humility. Here is the list of the 12 anomalies that do not disappear under trivial explanations. Memorize them, share them, demand answers. 1. Retrograde trajectory aligned with the ecliptic plane. Atlas is moving backward relative to most objects in our solar system, yet it stays perfectly aligned with the plane where planets orbit. This is statistically unusual for a random interstellar object. 2. Sunward jets and anti-tail, clearly not a geometric illusion. Normal comets have tails that point away from the sun due to solar wind. Atlas has jets pointing toward the sun and a pronounced anti-tail. This defies basic cometary behavior. 3. Nucleus mass far larger than previous interstellar objects while still moving fast. Atlas is significantly more massive than Oumuamua or 2I Borisov, yet it maintains high velocity. This combination is difficult to explain naturally. 4. Arrival timing that enables close approaches to Mars, Venus, and Jupiter. The trajectory seems almost calculated to pass near multiple planets at optimal times. Coincidence? Maybe, but it's worth noting. 5. Gas plume containing an unusually high nickel content. Spectroscopic analysis revealed nickel levels far higher than expected in typical cometary material. This suggests an unusual composition. 6. Plume with very little water, approximately 4% by mass. Most comets are primarily water ice. Atlas has almost none. This alone makes it an outlier. 7. Extreme negative, unprecedented optical polarization. The light reflected from Atlas shows polarization characteristics never before recorded in any comet. This suggests the surface or surrounding material has unique properties. 8. Arrival direction near the WOW signal. Atlas's trajectory traces back to a region of space near where the famous WOW signal was detected in 1977. This could be pure coincidence, but it adds to the intrigue. 9. Rapid brightening and increasingly blue tone, bluer than the reference star. As Atlas approached the Sun, it didn't just get brighter, it changed color in ways that don't match cometary models. 10. Jets requiring an absorbing area incompatible with the estimated nucleus. The energy needed to produce the observed jets would require a surface area larger than what high-resolution imaging suggests the nucleus actually has. 11. Non-gravitational acceleration, implying massive mass loss of about 13% with no detectable cloud. Atlas is accelerating in ways that suggest it's losing significant mass, yet we don't see the expected debris cloud. Where is the material going? 12. Collimated jets maintaining orientation for millions of kilometers despite rotation. Even as Atlas spins, the jets remain tightly focused and directional. This is not how natural outgassing behaves. Each item is serious. Together, they form a set of anomalies calling for broad, transparent investigation. So what does all of this actually mean? Let's be clear about what we know and what we don't. We know Atlas is behaving in ways that challenge our current models of cometary physics. We know multiple independent observers have documented these anomalies. We know the scientific community is taking this seriously enough to propose dedicated observation campaigns. What we don't know is whether these anomalies point to exotic natural processes we haven't encountered before, or whether they suggest something more extraordinary. The technological hypothesis that Atlas could be an artificial object remains speculative but not dismissible. The plasma entity hypothesis is even more speculative but addresses some of the stranger observations, like the color changes and the self-organizing jet structures. What's important is that we approach this with both open minds and rigorous standards. Extraordinary claims require extraordinary evidence, but we also can't dismiss extraordinary evidence simply because it makes us uncomfortable. The next few weeks are critical. As Atlas continues its journey through our solar system, we have a limited window to gather more data. Spectroscopic analysis can tell us more about composition. High-speed imaging can reveal whether the jets truly behave like propulsion systems. Coordinated observations from multiple locations can help us understand the three-dimensional structure of these jets. What we need is transparency. Amateur astronomers are capturing incredible images and sharing them openly. Professional observatories need to do the same. If there are images or data being withheld, the public has a right to know why. We also need collaboration. This isn't a problem for one institution or one country. If Atlas represents something truly anomalous, it's a discovery that belongs to all of humanity. Folks, what the new images of Atlas show is clear. Its behavior does not fit comfortably inside the box of natural comets. We have multiple hypotheses on the table, from exotic particles to artificial propulsion to plasma structures, but none is definitive. What we do have is a consistent set of real anomalies observed by multiple specialists and recorded across different instruments. And that means the story of Atlas is far from over. This could be the most important astronomical discovery of our generation. Or it could be a natural phenomenon that teaches us something profound about cometary physics. Either way, we're witnessing something extraordinary. The question isn't whether Atlas is strange, it clearly is. The question is what kind of strange it is, and we won't know the answer unless we keep watching, keep questioning, and keep demanding transparency from those with the tools to investigate. Now I want to hear from you. Which one of these anomalies caught your attention the most? And which hypothesis makes the most sense so far? Leave your comment below. I read every single one. Subscribe to the channel and turn on notifications because the next few weeks are going to be intense. We're going to be covering every new development as it happens. And if you want to dive even deeper into this mystery, click on the video appearing on your screen right now, where we break down the full trajectory analysis and what it tells us about Atlas's origins. I'll see you there.